Hi, welcome to Student Pilot Bertram. It's time to get rid of the last part of chapter 3 on weather information. We did 3.1, and I decided to give you a little break because it's a long chapter and it's kind of dull stuff, so I wanted to break that chapter 3 up a little bit. And then you got that little bonus at the end, and if you haven't seen that, go watch the video because I'm not going to tell you what it was. So, since Thanksgiving tomorrow, I'm gonna do this to now and we'll get going. So we'll start again with C, aviation, weather reports and observations. Number 1, what is a meta, and what are the two types? A meta is an hourly service observation of conditions observed at an airport. There are two types of meta reports: a routine meta report that is transmitted every hour, and an aviation selected special weather report. This is a special report that can be given at any time to update the meta for rapidly changing weather conditions, aircraft mishaps, or other critical information. Number 2. Describe the basic elements of a meta. The type of reports, the time, the density, the dew point, the altimeter, the pressure, and the clouds. It's probably not correct, but let me see. A meta report contains the following elements in order as presented. A. Type of reports, the metas, and the SPECI Aviation Special Weather Report. B. ICAO Station Identifier, 4-letter station identifiers. In the contaminous US, the 3-letter identifier is prefixed with a K. So yeah, that's why airports have Ks in front of them. Then the date and time of the report, a 6-digit date time group apprehended with a Z was UTC. First 2 digits are the date, then 2 for the hour and 2 for minutes. Modifier as required. If used, the modifier auto identifies the report as an automated weather report with no human intervention. If auto is shown in the body of the report, A01 or A02 will be encoded in the remarks section to indicate the type of precipitation sensor used at this station. C. Wind, which is what I said. I got partially right. Wind, 5-digit group, 6 digits if speed is over 99 knots. First 3 digits, wind direction in 10 degrees. Truth, in 10 degrees reference to true north. Directions less than 100 degrees are preceded with a 0. Next 2 digits are the average speed in knots measured or estimated, or if over 99 knots, the next 3 digits. F is visibility, service visibility, that's what the SM stands for, in statute miles, space, fractions of statute miles as needed, and the letters SM. And G, runway visual range, RVR, as required. H, weather phenomena, broken into categories qualifies as weather phenomena. I is sky condition, amount of height, type as required or indefinite, ceiling height, vertical visibility. Heights are recorded in feet, AGL. Above ground level, that means AGL, above ground level. J, temperature dew point group, 2-digit format in whole degrees Celsius separated by a solidus, which is a /. Temperatures below 0 are prefixed with an M. Altimeter, 4-digit format represented and units. 4-digit format representing tens, units, and tenths. The first digit after the decimal point, the tenths. And hundredths of inches of mercury prefixed with an A. The decimal point is not reported or stated. And then L, remarks. RMK, as required, operational significant weather phenomena, locational phenomena, beginning and ending times, direction of movement. Example, Meta KLAX, that's Los Angeles Airport. Then it's 140651 Zulu. So 14 is the date, 06 is the hour, 51 is the minutes, and Z for Zulu time, UTC, which it's from the East Coast New York time where I am, that's 5 hours ahead. And it's auto, and it's 000 knots. 1 statute mile of visibility. And R35L / okay, I'm not used to that one. Then we got 10. We got rain and cloud breaking at zip north 030. 10 forwards 10, dew point 10. Altimeter is 29990. Remark AO2. 3. Describe several types of weather observing programs. A. Manual observations. With only a few exceptions, these reports are from airport locations staffed by FAA personnel who manually observe, perform calculations, and enter the observations into the communication system. B. AWOS, Automated Weather Observance System, consists of various sensors, a processor, a computer-generated voice subsystem, and a transmitter to broadcast local minute-by-minute weather data directly to the pilot. Observations will include the prefix auto in the data. And if you haven't, I really recommend you take a look at the bonus section in the previous video for this series. C. ASOS / AWSS, Automated Service Observation System, Automated Weather Sensor System. The primary U.S. Service Weather Observance System, AWSS, is a follow-on program that provides the identical data as ASOS. Both systems provide continuous minute-by-minute observations that generate metas and other aviation weather information transmitted over a discrete VHF radio frequency or the voice portion of a local nav aid, and are receivable to a maximum of 25 nautical miles from the station and a maximum of altitude of 10,000 feet AGL. Observations made without human intervention will include the modifier auto in the report data. Number 4. What are PIREPs, UA, and where are they usually found? They're the pilot reports. A pilot report, PIREPs, provides valuable information regarding the conditions as they actually exist in the air, which cannot be gathered from any other source. Pilots can confirm the height of bases and tops of clouds, locations of wind shear and turbulence, and the location of in-flight icing. There are 2 types of PIREPs, routine or UA, and urgent or UUA. PIREPs should be given to the ground facility with which communications are established, i.e. FSARTCC or Terminal ATC. Altitudes are MSL from sea level. Visibility is SM, and distances in NM. PyReps are available from an FSS and on the internet via the ADDS webpage at AD. I'll put the link on the description. D. Aviation weather forecasts. What are terminal aerodrome forecasts? TAFs. A terminal aerodrome forecast (TAF) is a concise statement of the expected meteorological conditions significant to aviation for a specific time period within 5 statute miles (SM) of the center of the airport's runway complex terminal. The TAFs use the same weather codes found in meta weather reports in the following format. A. Types of reports. B. ICAO. C. Date and time of origin. D. Valid period, date and time. And E. Forecasts. Number 2. Defined aviation area forecast. Abbreviated as FA, this is a forecast of specific weather phenomena covering a flight information region or other area designated by meteorological authority. Pilots should use the area forecast in conjunction with Hermes, Sigmets, and Convective Sigmets, CWAs, etc. to determine forecast in route weather, and to interpolate conditions at airports that do not have a terminal aerodrome forecast. FAs are issued 3 times daily for each of the 6 areas in the contiguous 48 states. FAs are also issued for the Gulf of Mexico, the Caribbean, Hawaii, and Alaska. Most area forecasts were cancelled in 2017, replaced by GFAAs. Number 3. What information is provided by an FA? Area forecasts are issued for continuous US and cover the airspace between the surface and 45,000 feet above medium sea level, AMSL. They include a synopsis, a brief discussion of the synoptic weather affecting the FA area during the 18-hour flying period. B. Clouds and weather, description of the clouds and weather for the first 12-hour period for each state or group of states, including cloud amount, cloud bases and tops, precipitation, visibilities, and sustained surface winds 20 knots or greater. C. 12 to 18 hour categorical outlook, IFR marginal VFR, which is MVFR, which we saw on the app the other day for Gabe, or VFR, including expected precipitation and or obstruction to visibility. Note, plans are to discontinue the 6 FAs covering the Conus and 1 FA covering Hawaii, and subsequently replace them with digital and graphical products, GFA, produced by the NWS. No near-term changes are planned for the FAs for Alaska, the Caribbean, or the Gulf of Mexico. What is a graphical forecast for aviation? The GFA is intended to provide the necessary aviation weather information as a complete picture of the weather that may impact flight in the continental US. The web page includes observational data, forecasts, and warnings that can be viewed from 14 hours in the past to 15 hours in the future, including thunderstorms, clouds, flight category, precipitation, icing, turbulence, and winds. Number 5. What are the 4 types of in-flight aviation weather advisories? In-flight aviation weather advisories are forecast to advise in-route aircraft of the development of potentially hazardous weather in four types: the Sigmet WS, the Convective Sigmet WST, the AirMet WA text or graphical product, and the Center Weather Advisory CWA. All heights are referenced MSL, except in the case of ceilings, CIG, which indicate AGL. Six. What is a convective Sigmet? Convective Sigmets WST implies severe or greater turbulence, severe icing, and low wind shear. They may be issued for any convective station which the forecaster feels is hazardous to all categories of aircraft. Convective Sigmets bulletins are issued for the Eastern E, Central C, and Western W United States. Convective Sigmets are not issued for Alaska or Hawaii. Bulletins are issued hourly at hour plus 55. In other words, H plus 55. Special bulletins are issued at any time as required and updated at H plus 55. The text of the bulletin consists of either an observation and a forecast, or just a forecast. The text of a bulletin consists of either an observation and a forecast, or just a forecast. The forecast is valid for up to 2 hours. A. Severe thunderstorms due to surface winds greater than or equal to 50 knots. Hail at the surface greater than or equal to 3/4 inch diameter, or tornadoes. Yeah, if there's tornadoes, it's probably not a good idea to go flying. B. Embedded thunderstorms. C. A line of thunderstorms. D. Thunderstorms producing greater than or equal to heavy precipitation that affects 40% or more of an area at least 3,000 square miles. 7. What is a Sigmet WS? A Sigmet WS advises of weather that is potentially hazardous to all aircraft. Sigmets are unscheduled products that are valid for 4 hours. Sigmets associated with tropical cyclones and volcanic ash clouds are valid for 6 hours. So this is probably more relevant for Hawaii and stuff like that. Unscheduled updates and corrections are issued as necessary. In the continuous US Sigmets are issued when the following phenomena occur or are expected to occur. A. Severe icing not associated with thunderstorms. B. Severe or extreme turbulence or clear air turbulence CAT not associated with thunderstorms. C. Widespread dust storms or sandstorms lowering surface visibility to below 3 miles. And D. Volcanic ash. 8. What is an AirMet? AirMet, in other words, WA. Advisories of significant weather phenomena that describe conditions at intensities lower than those which require issuance of Sigmets intended for use by all pilots in the pre-flight and en-route phase of flight to enhance safety. AirMet information is available in 2 formats: text bulletins WA and graphics GAirMet. They are issued on a scheduled basis every 6 hours, beginning at 02:45 UTC. Unscheduled updates and corrections are issued as necessary. Each AirMet bulletin includes an outlook for conditions expected after the AirMet valid period. AirMets contain details about IFR, extensive mountain obscuration, turbulence, strong surface winds, icing, and freezing levels. Number 9. What are the different types of AirMets? There are 3 AirMet types: Sierra, Tango, and Zulu. AM at Sierra describes IFR conditions and or extensive mountain excursions. BM at Tango describes moderate turbulence, sustained surface winds of 30 knots or greater, and or non-convective low-level wind shear. Zulu describes moderate icing and provides freezing levels and heights. Number 10. Describe the winds and temperature aloft forecasts. Winds and temperature aloft forecasts are a computer-prepared forecast of wind direction, wind speed, and temperature at specific or specified times, altitudes, and locations. They are produced 4 times daily for specific locations in the continental United States, Hawaii, Alaska, and coastal waters, and Western Pacific Ocean. Amendments are not issued to the forecast. Wind forecasts are not issued for altitudes within 1,500 feet of a location's elevation. Some of the features of FBs are: a product header includes date and time observations collected, forecast valid date and time, and the time period during which the forecast is to be used. B. Altitudes up to 1,500 feet referenced to MSL. Altitudes at or above 1,800 feet are references to flight level FL. C. Temperatures indicated in degrees Celsius, 2 digits, for levels from 6,000 through 24,000 feet. Above 24,000 feet, minus sign is omitted, since temperatures are always negative at those altitudes. Temperatures forecasts are not issued for altitudes within 2,500 feet of a location's elevation. Forecasts for intermediate levels are determined by interpolation. D. Wind direction indicates tens of degrees, 2 digits, with reference to true north, and wind speed is given in knots, 2 digits. Light and variable wind or wind speeds less than 5 knots are expressed by 9900. Forecast wind speeds of 100 through 199 knots are indicated by subtracting 100 from the wind speed and adding 50 to the coded direction. For example, a forecast of 250 degrees, 145 knots, is encoded as 7545. Forecast wind speeds of 200 knots or greater are indicated as forecast speed of 199 knots. For example, 799 is decoded as 270 degrees at 199 knots or greater. Number 11. What valuable information can be determined from winds and temperature aloft forecasts? Most favorable altitude based on winds and direction of flight. Areas of possible icing by noting air temperatures of +2 Celsius to -20 Celsius. Temperature inversions, turbulence by observing abrupt changes in wind direction and speed at different altitudes. What are Center Weather Advisories, CWA? A Center Weather Advisory, CWA, is an aviation warning for use by air crews to anticipate and avoid adverse weather conditions in the en route and terminal environments. The CWA is not a flight planning product. Instead, it reflects current conditions expected at the time of issuance, and or is a short-range forecast for conditions expected to begin within 2 hours of issuance. CWAs are valid for a maximum of 2 hours. If conditions are expected to continue beyond the 2-hour valid period, a statement will be included in the CWA. Told you it's a lot of dry stuff. It's a big chapter, chapter 3. Section E, aviation weather charts. Give some examples of the various NWS weather charts you will use during pre-flight planning. A. Service analysis chart. B. Weather depiction chart. C. Short-range service prognostic chart. D. Significant weather prognostic chart. E. Convective outlook chart. F. Constant pressure analyst chart. Number 2. What is a service analyst chart? Service analyst charts are analyzed charts of surface weather observations. The chart depicts the distribution of several items, including sea level pressure, the positions of highs and lows, ridges, troughs and location and character of fronts, and the various boundaries such as dry lines, outflow boundaries, sea breeze fronts, and convergence lines. The chart is produced 8 times daily. What information does a weather depiction chart provide? The weather depiction chart contains a plot of weather conditions at selected meta stations and analysis of weather flying category, VFR, MVFR, or IFR. It is designed primarily as a briefing tool to alert aviation interest to the location of critical or near critical operation minimums at terminals in the continuous U.S. and surrounding land areas. The chart issued 8 times daily. Number 4. Define the terms LIFR, IFR, MVFR, and VFR. LIFR means low IFR ceiling less than 5,000 feet and or visibility less than 1 mile. IFR ceiling 500 to less than 1,000 feet and or visibility 1 to less than 3 miles. MVFR, marginal VFR, ceiling 1,000 to 3,000 feet, and or visibility 3 to 5 miles inclusive. VFR, ceiling greater than 3,000 feet and visibility greater than 5 miles, includes sky clear. 5. What are short-range surface prognostic charts? Short-range surface prognostic (PROG) charts provide a forecast of surface pressure systems, fronts, and precipitation for a 2.5-day period. They cover a forecast area of 48 contiguous states and coastal waters and are prepared by the NWS Weather Prediction Center and available on the AWZ website. Predicted conditions are divided into 5 forecast periods: 12, 18, 24, 48, and 60 hours. Each chart depicts a snapshot of weather elements expected at the specified valid time. Charts are issued 4 times a day and can be used to obtain an overview of the progression of surface weather features during the included periods. Number 6. Describe a U.S. low-level significant weather PROG chart. The low-level significant weather (SIGWX) charts provide a forecast of aviation weather hazards primarily intended to be used as guidance products for pre-flight briefings. The forecast domain covers the continual U.S. and coastal waters for altitudes flight level 240 and below. Each depicts a snapshot of weather expected at the specified valid time. The charts depict weather flying categories, turbulence, and freezing levels, and are issued for 4 times per day in 2 types, a 12-hour and a 24-hour PROG. Number 7. Describe a mild level significant weather SIGWX chart. The mid-level significant weather chart provides a forecast and an overview of significant in-route weather phenomena over a range of flight levels from 10,000 feet MSL to flight level 450, and associated service weather features. The chart is a snapshot of weather expected at specified valid time and depicts numerous weather elements that can be hazardous to aviation. The AWC issues the 24-hour mid-level sniffing weather chart 4 times daily. Number 8. What is a convective outlook chart? The convective outlook chart depicts areas forecast to have the potential for severe tornado wind gusts 50 knots or greater, or hail 3/4 inch diameter size or greater, and non-severe general convection and specified severe weather threats during the following 3 days. The chart defines areas of slight risk, moderate risk, or high risk of severe thunderstorms for a 24-hour period beginning at 1200 UTC. Day 1 and Day 2 convection outlooks also depict areas of general thunderstorms, while the Day 1, Day 2, and Day 3 convective outlooks may use see text for areas where convection may approach or slightly exceed severe criteria. What are consistent pressure analyst charts? Any surface or equal pressure in the atmosphere is a constant pressure surface. A constant pressure analyst chart is an upper air weather map where all information depicted is at the specified pressure of the chart. From these charts, a pilot can approximate the observed air temperature, wind, temperature, and dew point spread along a proposed route. They also depict highs, lows, troughs, and ridges aloft by the height contour patterns resembling isobars on a surface map. Twice daily, 5 constant pressure charts are issued from observed data obtained at 0 Zulu and 12 0 to midnight and midday. 850 MB at 5,000 feet, 700 MB, that doesn't really matter. Examiner, be prepared to interpret and discuss current and forecast weather along your planned route of flight. The evaluator will want you to demonstrate that you can interpret the various aviation weather reports, forecasts, charts, graphics, and make an assessment of how it will affect your planned flight. We finally reached the additional study questions. Dun, dun, dun. Number 1, when evaluating the weather reports and forecasts during your pre-flight plan, what process will you use to make a go, no-go decision? You check the Hermes, you check the Sigmets, you check the ATIS information from the departure. You could check the weather at the arrival, but that may not be wise. I mean, you can call the number of the airport, but that tells you what it is now, not what it's going to be. You can look at the CWAs. Since I'm a private pilot, I would make sure that the weather was VFR conditions. If it's modified VFR, I probably wouldn't go, because I have a feeling that you would need to have some sort of instrument rating before you can fly that, just in case you get into trouble. So if the conditions are not VFR, if there's ice or storms or severe weather, it would be a no-go decision. Number 2 we don't need to worry about because it's you won't be able to see the question, so there's no point answering. So yeah, number 2 and number 3 is just decoding a bunch of metas, which I may put these questions in the description for you guys to answer, because I think that's best where you're going to get. What are symbols used to depict the following frontal systems? Yeah, I'm gonna put these terminal questions, the additional study questions, in the description below, because there's no point me reading them, because it's gonna sound like a whole lot of numbers and stuff like that, and it's not gonna make sense. It's something that's better you do as you're reading. So if you watch the video 3.1 and then watch this video 3.2, it will give you the answers to be able to answer these additional static questions, or it should at least. Alright, so that's the end of part 3. The next one, part 4, is performance and limitations. So we're getting there. There's only 9 chapters, so we're at chapter 4 already. So if I don't do any other video, go have a good holiday, happy Thanksgiving. That is, if you're in the US, it's tomorrow. So adios.